Okay, so I guess it's starting now. Okay, so thanks for coming today, guys. So today I'll talk about comets, asteroids, and meteorites. So they are all space rocks, but why are they termed differently? So firstly, what are comets? Yeah. So what are comets? So comets are made out of ice, dust, and rocky particles, and they have three main parts to them. So we can see that there's a core, there's a coma, and there's a tail. So when the comet is far, far away from the sun, basically when it does not face any radiation pressure from the sun, it reaches the core. But as the core moves closer towards the sun, towards the inner solar system, the heating from the radiation pressure of the sun boils the ice particles in the comet, and this together with the dust particles form your coma, which is your huge empty atmosphere around the core. And as it goes even closer to the sun, the radiation pressure from the sun would blow the gas and dust away from the coma towards the tail. So even though the picture we see here, the core looks circular, it's actually most comets, the cores are actually irregular. And this is because they are very light, they do not have enough material to become spherical under their own gravity. So the coma and the tail are both illuminated by the sun. So the dust reflects the sunlight directly, whereas the gases in the coma and the tail blow from ionization. So, but then do we notice there's a dust tail and a gas tail? So why are there two tails of the coma? So the dust tail, as the name states, is the tail that is formed by the dust particles in the coma. So the dust tail that we notice, it curves away and it follows the orbital path of the comet, whereas the gas tail points directly away from the sun. The reason why the dust and gas particles would separate is because, as mentioned earlier, the gas glows due to ionization, so it's electrically charged, and is more affected by the solar wind than the dust particles. So generally, comets have very highly eccentric elliptical orbits. So this means that they are closer to being oval than circular. So there's also a very wide range of orbital periods. Generally, if the orbital period of the comet is short, and by short it generally means less than 200 years, we generally assume that it originated from the Kuiper belt, because we do not know exactly where the comets originate from. But if they have a shorter orbital period, we usually assume that their orbit goes from the outer planets, that is aphelion, towards the sun and go back out again. But if the orbital period is very long, then we might assume that it originated from the Oort cloud, which is even further than the Kuiper belt, because it's in the outer it's further than Pluto in the outer solar system. So originally, these comets are within the Kuiper belt or the Oort cloud, but then due to gravitational perturbations by the passing stars or the tidal effect of our Milky Way galaxy, these comets which were previously resting over there would be set in motion towards the sun. So actually this whole idea is actually known as the Oort cloud hypothesis, because this means that we assume that the comets were not always in their current orbit, which kind of makes sense because as the comets keep passing by the sun, for them to form their tail, the ice particles would have to keep boiling. So this means that it's not very sustainable and the comets will actually eventually die out. So it means that chances are for the most of the lifetime of the comets, they were originally either in the Kuiper belt or the Oort cloud. So this is the orbital path of the very recent comet, which is the comet Neowise. So as we can see from the orbital path, it's very elliptical and it goes near the sun before going back out to the outer solar system. So one reason why the comet was actually quite bright also is because we noticed that it's in retrograde motion. So retrograde motion means that compared to the rest of, we notice all the planets is going in anti-clockwise, whereas the comet is going in the other direction. So this means that when it passes through the Earth's atmosphere, it actually goes against it, which results in its relative speed being faster. And this means that it will heat up more and be brighter. Yeah, so this is a picture of the comet near-wise, and we can notice that there's two tails over there. So the one that's more straighter, which is this one, would be the gas tail, whereas this one would be your dust tail. Yeah, so this comet is another comet, which is your famous Halley's Comet, which previously passed by Earth, I think in 1980 something, and it will come back again in 2061. So we notice that it's like the time between is quite short, because your Halley's Comet is considered a short orbital period comet with an orbital period of just 71 years. So it probably originated from the Kuiper Belt. So next, asteroids. So where do asteroids come from? Where are they now? So asteroids generally are in 3 different places. So most of them actually orbit within your asteroid belt, which is between the orbits of Mars and Jupiter. So this place is estimated to contain more than 1 million asteroids. So due to the gravitational effect of Jupiter, asteroids are actually prevented from accreting into planets during the earlier times of the solar system, which is why over there is just a lot of asteroids, but there isn't a planet there. In fact, this is an interesting thing to note, because in the next slide I'll talk about the first asteroid that was discovered and why they thought it was a planet at first. And the next thing is that asteroids could also be Trojans, which means that these are asteroids that share an orbit with a larger planet or moon. So as we can see over here, there are the Jupiter Trojans over here in the same orbit as Jupiter. So they are able to remain stable even though they are in the same orbit as a planet, because they rest at one of the Lagrangian points of the bigger body, which is your L4 and L5 respectively. So this allows them to remain in the stable orbit. So Jupiter is not the only planet that has Trojans, even though the Jupiter Trojans are the most notable. There are also Trojans around other planets as well, like even Earth, Venus and Mars. So the last one is just, as the name suggests, near-Earth asteroids, which means these orbit close to Earth. And more specifically, it means that the orbit of these asteroids actually cut into the orbit of the Earth around the Sun. So Ceres is the largest asteroid, and it's also the first asteroid that we found. So how did they even find Ceres? So this was back in the 1700s when this guy called Bode, which is B-O-D-E, he was hypothesizing that there's probably a planet in between the region of Mars and Jupiter, because there's a huge region over there. This was before they discovered the asteroid belt. So they were thinking, okay, there's probably a planet there. And also in the same century, that was when they also discovered Uranus, which followed their calculations and their hypothesis of where the planet was. So they were thinking, okay, this further proves that based on our calculations, there's probably a planet over there. So they tried to observe and they managed to find Ceres, and they thought, okay, maybe this is the planet that we're trying to find. So at first they called it a planet. But then later on they realized, actually in the area they managed to observe a lot of other rocks that were quite similar to Ceres also, just that they were all smaller. So they realized, okay, so we need a new category for this, because these are not planets. So that's how they called it asteroids. And now Ceres is officially not an asteroid, it's actually a dwarf planet. It's after they came up with another term for it. But it's still officially the first and the largest asteroid that we have found. And then another notable asteroid is Vesta. So Vesta is actually the brightest asteroid that we can see. In fact, I think in 2018 it was so bright that we could have possibly seen it with our naked eye. So why is Vesta so bright even though it's not the largest asteroid? So the reason why is because the surface of Vesta is actually very reflective. So that means the material or the minerals on Vesta is actually very reflective. So this allows it to reflect a lot of light from the sun, which makes it very bright. So we've gone through comets, we've gone through asteroids. Before I touch on meteorites, what exactly is the difference? Because so far they just sound like space rocks. So asteroids are mostly mineral and rock, whereas comets are mostly dust and ice. So that means asteroids do not really have ice, and this is because they form closer to the sun. Because we notice that the places where asteroids are mostly at, which is your Kuiper Belt, your near the planets, as well as near the Earth, these are nearer to the inner solar system, which means that your cometary ice couldn't really form. So this results in your asteroids being mostly mineral and rock, and it doesn't really have a tail when it moves near the sun. Whereas the difference between asteroids and meteorites is purely due to size. So your asteroids are quite big. We generally take asteroids to be 1 meter or more. Their meteorites are smaller, so they have a diameter of 1 meter or less. So if your meteorites were any smaller, they'll be called micrometeorites or just space dust. So now we go to meteorites. So as mentioned earlier, meteorites are much smaller than asteroids, and they range from 100 micrometers to 1 meter in size. So some are fragments from collisions, some are fragments from comets or asteroids, but the rest are collision impact debris from bodies such as the Moon or Mars. So that means when something impacted Moon or Mars, the space debris that flew out into space could have formed our meteorite. So, but then we heard the term meteor, meteorite. So what is the difference between all these terms? So a meteoroid is the small space rocks in space, whereas a meteor is when the meteorite moves through the atmosphere at a very high speed. So your meteor shower is what happens when you have a lot of meteors within minutes of each other or seconds of each other, and they appear to originate from the same point in the sky. Whereas finally your meteorite is what's left of the meteoroid after it hits the ground. So where do the colors of your meteors come from? So the visible light produced by a meteorite might take on different colors depending on the chemical composition of the meteoroid and the speed of its movement through the atmosphere. Also, as the layers of, because your meteorite might not be completely the same material, so as the layers of it slowly ionize and abrade off, the color of the light emitted may change according to the layering of your materials. So the colors of meteors depend on the relative influence of the metallic component of your meteorite and how it interacts with the air that's around it. So generally there's a lot of things to look at when you try to analyze the color, but some things to note also is that if you see generally these few colors, you could sort of take that there is these elements or materials either inside the meteorite or in the air that is going through. Okay, so what about our meteor showers? So meteors appear to radiate from single point in the sky. So why is that? Because these particles actually all travel in parallel paths and at the same velocity. So hence they all appear to radiate from a single point in the sky. It's the same logic as how when you have a train traveling on, when you have train tracks, then they appear to converge to a single point even though they are parallel. Yes. So meteor showers are almost always named after the constellation from which the meteors appear to originate. So anyone like to guess which meteor shower is this? Okay, good try. It's not your Geminids. Yes. How did you guess? Yes. So because there's the constellation Perseus inside here, which is this Y shape over here, this is how we tell that this is the Perseus meteor shower. So a list of meteor showers is very long, but I'll just point out a few prominent meteor showers. And why do I say these are prominent? Because, for example, how do we know which meteor shower we try to look at and which ones we probably have a lesser chance of looking at? So one thing that we look at is this ZHR over here. So what is this? So it actually stands for your zenithal hourly rate. So what this means is just the number of meteors you would see passing by the zenith, which is right above you. So it simply means the number of meteors passing by overhead within an hour. So basically, the higher your number, generally there's more meteors to see under that meteor shower. And also another thing we notice is that the meteor showers all have a parent body. So why is that? It's because from your parent body, especially your comets, as they travel through, as your comets outgas, which just now I mentioned is when the coma and the tail would leave behind material in its path. So this is the path that the Earth actually travels through as well. So every year when we go through the same path, all this material that is left behind will go through the atmosphere and form our meteor showers. And this is why we can have annual meteor showers even though the parent body is not always there. It's because what we are going through is not the asteroid or the comet itself, but what was left behind in its path. And one thing we notice is that there's two meteor showers which has a parent body of the Halley's Comet, which is your Eta Corentids and your Orinids. So okay, that's interesting. Like why does these both meteor showers both have the same parent body when it only comes by one time? So the reason because of that is because this is your path of your Halley's Comet. So when your Halley's Comet comes towards the Earth's path over here, the debris that is left behind around this area results in your Orinids. And then as it goes around the sun and goes to the other side, the material that is left over here is your Eta Corentids. So currently, in 2016, it just reached the other end of its orbit, and it will take all the way until 2061 before it will come back past Earth again. But in the meantime, we can still see the two meteor showers when the Earth passes by this region. Okay, with that, it's actually the end of the talk. Does anyone have any questions? Okay, if not, I hope you all been paying attention because there's Kahoot. Can I just... Like this sound instead. Okay. Yeah, how do I click it? Yeah. Is it control? Yeah, it's like you must literally like click it. Then you must turn around and click. Turn around. Yeah. Oh, so I. The second later. So I. Oh, okay. Is that everyone? Is anyone else joining? No one joining our star. Anyone was paying attention to the table? Okay, so your live reads are around April and your germinates are around the end of the year in December. So these two are around July, August. Okay, so Edmund Halley was the first person to predict the return of the comet, and specifically the Halley's Comet. So the Halley's Comet is the one of the few comets that were not named after its discoverer, but instead Halley, because he was the first one that predicted that it will come back after repeated observations of the Halley's Comet. Yes, correct. So it's these two because your path of your Halley's Comet is the last slide just now. Okay, so this is an actual thing. So a fireball is officially when your meteor is brighter than a planet. So when it has a magnitude of -4 and above, it's called a fireball. Yep, so comets have a lifetime because the ice particles in it slowly gets brought to form your tail and form your coma and your tail. So there's only so much ice particles that you can boil after going past the sun. So sooner or later the comets will become extinct. And actually when it becomes extinct, it becomes very similar to an asteroid. Okay, so not bad. So there are empty spaces. So these empty spaces is actually due to resonance with the other planets, specifically Jupiter. So this causes there to be actually a few empty spaces within the main asteroid belt, which is between Mars and Jupiter. So there's more than one gap, which is why it's your Kirkwood gap. Your Cassini division is actually the gap between the rings of Saturn, and your Van Allen belt is the radiation belt near the Earth. Okay, so there is actually a way. So there is a way to tell from the name itself. So for your asteroid, the first name that is applied to the asteroid. So sometimes asteroids have two names. So the name that's applied later is after they confirm the orbit of the asteroid. Then they ask the person who discovered it, what would he like to name it. But this original name, the first four numbers is the year that it was discovered. Then the first letter actually means which. For example, A means from January 1st to January 15th. And B means from January 16th to the end of January. So every letter means a half month. And you ignore I and you ignore the last letter. Then okay, the T, okay, you don't need the T and the 4 to tell when it was discovered. But what the T means is that was the, okay, if it wasn't a T, if it was an A, it means it was the first asteroid that was discovered during that time period. So what the T4 means, it means that if you go through the whole alphabet 4 times and then you go until a T, that's the number what asteroid you found during that time period. Yes, random interesting facts. Yes, so the parent comet or asteroid doesn't have to be near the Earth. If not, meteor showers will only occur whenever the comet passed by, which should be a few years, don't know how many years. Whereas a meteor shower actually occurs every year. And that is because the meteor shower occurs when the Earth passes through the dust and gas left behind from the comet or asteroid's path, which occurs every year. Last question. Okay, so a clue to you guys just now was when we were looking at the picture of the NUS comet, and then I mentioned that the one that was more straighter was the gas tail, whereas the one that was more curved was the dust tail. You notice that the dust tail is a lot brighter compared to the gas tail. Okay, thanks for participating. Okay, now I'll pass the time to Grace. Yes.
Telegram.
Is it showing?
No, only the mic.
me. You need to reply. You need to reply.
Got it.
Always me reply.
I close.
No, I can close it. Ah, just.
Okay.
Downloaded. I never mind. Open it. Can I edit something? Is this working? Yes.
Starting now.
Hi guys. Hi. Thanks Kai Wen for the very interesting talk. Right now I'll be covering observation highlights. What is observation highlight? It's just like yeah, so we will be giving observation highlight almost every week for this semester, and we'll be telling you guys more about like what can we see in the sky during like our usual sessions, and also what to take note of during the semester. What are some of the astro events that we can look out for during the semester. So this is the first observation highlight of the semester. So what I will be covering is to give you guys an overall introduction to what are some of the astronomical events that will be happening during this semester, in particular from January all the way to May. So let's start. So first of all, I just want to give a brief recap of this event that actually happened during the December holiday. So if you guys are with us during on this 21st of December 2020, we actually went to stadium to observe this event. So what happened was that a great conjunction of Jupiter and Saturn. I'm pretty sure like if you're actually following the news, right, you probably have seen this somewhere on the news before. Yeah, so what exactly is this? So it was actually like, to put it in simple terms, right, it's just like Jupiter and Saturn become so close together that they seem to overlap with one another lah. But in actual fact, they don't. It's just from our perspective, then it kind of like align with one another, such that it is very very close and it is able to fit into the same field of view inside a telescope lah. Later we'll see a few of the pictures that are taken by our members and also some of our by NTU Astro also. So thanks to our member here, one of our EXCO member here, he actually captured like the distance of the Jupiter and Saturn day by day as we get closer to the conjunction itself. Yeah. So from the, as you all can see, right, like you all see the two brightest dot there. Then you get closer and closer and closer and closer, and then finally on 22nd you get like that close. Yeah. And it is special because it occurs every 20 years when Jupiter overtakes Saturn in its orbit and they align. So that's why we have this phenomenon called the Great Conjunction. And the next time when we can observe this is actually going to be in 2080. Yeah. So if you miss this one, then 2080 maybe you can catch the next one. Yeah. But if not, so with our naked eye, what we actually see
I'm not really sure whether you can see on the screen, but if y'all can, you'll be able to see like a tiny little. It's actually 2 dots, but yeah. So from here you can see that it's seemingly one dot, but it's actually 2 dots. Yeah. This is both Saturn and Jupiter, and then through the binoculars, they can be slightly differentiated apart from each other. So pretty cool. Yep. And finally, through the telescope, we can see like the Jupiter and the Saturn in the same field of view. So what do I mean by same field of view? Means that if you set up a telescope and you point at this area in the sky, and then you put your eyes close to the eyepiece, then you'll be able to see 2 planets together inside when you glance through the telescope. Yeah. So in simple terms, it's put like that lah. So it's actually very special because normally we don't see that because we have to aim at both, like when we aim at like Jupiter and then we have to shift our telescope to point at Saturn to see Saturn lah. So for these, then we can just like point at one area, then haha, it's just there. Yeah. So just very special to us lah. Yeah, so let's move on to what can we see, what's special in the sky for this semester, what to look forward to. So firstly, this is the Moon and Mars conjunction. So just like I mentioned, like the Saturn and the Jupiter conjunction, right? Just like 2 planets kind of like become very, very close to each other. So same concept here, the Moon and Mars will appear kind of close to each other during conjunction at any other time. This one, right, is not as not really spectacular, and it occurs very, very often, but it's still kind of worth it to catch them in the night sky lah. So the frequency wise, right, actually you all see the dates, right? Today is 22nd, so yesterday is 21st, and today you will still be close. So later we can, if the sky is good, we can go out and then you can see like Mars and the Moon are distance wise, right? They are kind of closer to one another than any other time. And yeah, frequency is kind of frequent. So on 19th Feb, 20th of March, and 17th of April lah. So these are the dates. And the moon itself for today is actually waxing gibbous. What it means is just like, you know, half of the moon and a bit more. Yeah, you can see that half of the moon and a bit more, like ovalish kind of shape. Yeah. So another thing that is happening actually today, you guys are kind of lucky if the sky is good, and we will be able to see this one. It's called the Mars-Uranus conjunction. So same concept. Mars and Uranus will appear very close to each other during the conjunction, which is today. Yay! So if we are able to see, then we are lucky. But let's see, how are we able to find in the night sky? So this photo on the top is actually a picture taken from astronomy software we will use to find object in the sky. So show us where the object is in the sky, and then we'll just like follow whatever it is, and then we just try to find it. Yeah. So how to find it? Moon is very easy to find, right? So you just find the moon, and then you will kind of spot something that is like reddish orange kind of star nearby. So that is actually Mars. It's actually our planet Mars. So how do you find Uranus? You'll notice that Uranus is kind of close to Mars, right? So actually, because of Singapore's like pollution, and you know, we can't really see like objects that are kind of dim. So for Uranus, right, it has a the magnitude is actually 5 something, meaning it's not that easy for us to find. It actually has a light blue color. It's actually like bluish, but I don't think you'll be able to find like something bluish in Singapore's sky here lah. So if you see, like, you just scan around, if you find Mars, you just scan around the area. So if you are able to spot something that is like bright, then that is probably Uranus. Yeah. A bright dot. Yeah. We'll try to find if the sky is good. So the next thing that we will be able to look forward to is actually this thing called the Mercury Greatest Eastern Elongation. So what is this chim term here, right? It basically just means that Mercury will be at its highest point in the evening sky. So because you know, Mercury, right, it is very, very close to the sun. If you actually try to try to arrange the planets according to the sequence, right? And then you know that Mercury is super close to the sun, right? So it makes it for difficult for us to actually catch it because it rises and like sets at almost the same time with the sun. So when it's at the highest point, then you can kind of catch a glimpse of it lah. So the dates to note are 24th of Jan and also 17th of May lah. Yeah. How do we see it? This one is you need to find a very clear west view. So it means the sky must be good. If the sky is cloudy, then bad. If the sky is good, then you can try. You find facing the west, somewhere in the west. Then you will be slightly above the horizon shortly after the sunset. So after the sunset, then you quickly go and find it. And you may be able to see like some little white dot there in the horizon, and it's probably just Mercury. Yep. Yeah, so these are just like different dates and the timing that you will rise and set up. So just now, right, I say like 24th then, right, so it's just like 2 days from now. Then on 24th, if you all can see on 25th, the timing is 7:16 when the sun set, and the Mercury will set at like 8:30. So you just like during this period of time try to catch it in the west, and yeah, it's kind of low in the horizon. Yeah. So the next thing is western elongation. So actually it's kind of the similar concept, but instead of like during the sunset, it's during dawn. So before like the sun rises. If you guys want to wake up that early, then feel free to go out and then try to catch this event. Yeah. And how do you see it? It's this one, you need a east view. So before the sunrise, spot it in the east and try to find it. Yep. So these are the dates and stuff. Yeah, no worries. The slides, right? I'll try to make it available for all of you to see afterwards. And then the next thing to look forward to is the March equinox. So March equinox is not something it's not something that we can observe in the sky or whatever thing. It's just like a special day because it marks the first day of spring for the people living in the northern hemisphere and also the first day of autumn for people living in the southern hemisphere. So what is so special about this day is that on this day, right, the day and the night are of equal length, and it is happening on the 20th of March. Yep. Yeah, and this is actually kind of a special event also. So it's called the lunar occultation of Mars. So what actually happens is that if you guys can see the picture, right, Mars will pass by the moon and then get covered by the moon. And then you'll get covered by the darks, the dark side that is not really light up. And then you'll pass by, so the Mars will disappear. Then after some time, right, you'll reappear at the crescent side. Yeah. So yeah, just disappear and appear again. So this is the entire thing. So if you guys want to catch like Mars disappearing in the moon and then appearing again, like nothing has happened, right? Then it's happening on the 17th of April. Yeah. So exact timing. You need to find a northwestern sky at an altitude of 23.9 degrees at 21:21. And then from 21:21, right, it's 9:21 in the night, it will disappear because it will hide behind the moon, and then reappear again at 10:35 at a low altitude of 7.7 degrees. And then just now, Kai Wen mentioned about comet, meteor shower, and asteroids, right? So this is Eta Aquarius. So Eta Aquarius, right, is actually a meteor shower in the constellation of Aquarius. If you guys are paying attention just now, the reason why it's called Eta Aquarius is because of the constellation Aquarius. It is associated with the Halley's Comet. So the peak actually occurs on 6th May. And however, right, with the light pollution and also like the waning crescent moon, it is slightly unfavorable for us to catch it. So it's kind of challenging for us to catch it, but possible if the sky is clear, and you can try to view it in the week of 6 May. So it's like 6 May, then the week a few days before and after on the day itself. You can try for this thing. Then you may be able to catch something, but yeah. Yeah, generally meteor shower in Singapore, if you are enthused about it, you can try. Yeah. So how do you observe it, right? Is eastern sky. So around like 2:40 a.m. it will kind of rise. The radiant point will rise above the horizon till like dawn. So meaning 2:40 a.m. onwards, like maybe 3 a.m. right? You guys are still awake, right? 3 or 4 then until dawn, right? Then you kind of rise and you just stare in the east as it slowly rises. Yeah. And then this is something that we can look forward to. Yeah, we can look forward to it. And it's the total lunar eclipse. So what happened during a lunar eclipse? Basically, if you guys know what's blood moon, this is just blood moon. What happened during a lunar eclipse is that the Earth comes between the sun and the moon, so it blocks out the sunlight falling on the moon itself. So during a total lunar eclipse, right, the Earth shadow covers all of the moon surface, and it's happening on 26 May. But in Singapore, right, because this whole total eclipse, right, will last from 7:12 all the way to 7:26, and at 7:12 the sky is still bright, so we can see it, but you're not able to see it very clearly, like in a sense. So most likely, if you guys want to see like very, very clear, right, then yeah, and it's at 3 degree above the horizon, meaning horizon is just the flat ground. So 3 degree above means a little bit above, but we have a lot of buildings that is like blocking. So you need to wait for it to rise even further up. So when it actually rise even further up in the sky, right, the eclipse may already be, like the total eclipse, right, may already be gone and then become like it's no, yeah, it's partial already. Yeah, so we will be able to catch like the end of it lah, not like during the period itself, unless yeah. So this is the end of my presentation. There are a lot of events, so I will send the slides to upload it and then let you guys know. Thank you.